Thank you. So, my name is Edona, and I would like to start by apologizing for the dramatic decrease in expertise level from the Google people. I'm a researcher at the Graz University of Technology, and I'm passionate about these two topics, so basically digital identity and transparency systems. And I'm passionate about finding ways to integrate them with one another without breaking any of the guarantees that both systems provide. So just a quick introduction into user-centric digital identity frameworks, and especially on verifiable credentials. Just to get all of us in the same page, when I'm talking about credentials, we're talking about means to prove who you are online to different service providers. And there has been this in the past few years, and also on a national and also European level and also global level, this paradigm shift of rather having your identity scattered through all of these service providers and kind of losing control of where your data is going to more of a user-centric. So now you have all of your data in some app in your device, and now the user is in control of which part of this data to share with which service providers, and also even more privacy-preserving ways of proving to some service providers some attributes about you without showing the actual attributes. So what are the main actors? So we have some symmetry to the CT ecosystem. So we have some authority, which in our case are the issuers. And these issuers issue some credentials to a user. And this user saves and manages these credentials on this wallet application, digital identity wallet application. Further, this user presents these credentials in order to access some service of some service provider or a verifier. And the catch here is that we do not get the issuer to learn every time we're trying to log into a service provider. So what if we want to enhance this digital identity ecosystem and add some transparency layers to it? How could that look like? So this is a generic framework which is applicable to other ecosystems as well. But basically we would have this source or this authority which would log stuff in our transparency logs. And in our case, this could be either the issuer, which would log every time they issue a credential. This could be the verifier, which would log every time they are consuming this credential. Or this could be even wallet providers, which are the developers of the wallet application itself, which are publishing their binaries into this transparency log. And then we would have, of course, the tamper-proof append-only log in the center. We would have the consumer of this log, which again could be, depending on the application, could be several actors, either the verifier or the end user, and so on and so forth. Of course, we still need this all of this ecosystem of some way to publish digests of this log, and also to make sure that these logs are growing consistently, and the auditors that help verify those proofs and ensure those transparency guarantees. So how can transparency technology help? Of course, this is the case with other ecosystems as well, right? We get increased trust and accountability, and we ensure that the data that we're relying on can be trusted, and we detect if something has gone wrong. Basically, if some credential has been issued on behalf of me, but for somebody else who could impersonate me. And we also make it easier for auditors, in the sense of legal auditors, to automatically verify that an actor has been behaving correctly. And we also go more into this user empowerment lane, where we now give the user visibility of what's actually happening with his own data. But of course, the translation of these transparency principles into the digital identity context is not so straightforward, because we're dealing with highly sensitive data. So now we still want to maintain this public verifiability of the data that we're relying on, but we are dealing with private credentials and highly sensitive data. So we are running into the risk of actually having the risk of leaking and enabling some user tracking and correlation by having data being appended to these transparency logs. And these are the main issues that need to be solved when trying to adopt transparency logs for digital identity ecosystems. So I'm going to go into the main phases of the life cycle of a wallet and also like a digital credential, and see which transparency principles can be applied into which of these phases and how. The first one that comes to mind, of course, is wallet binary transparency, especially after the talk and after seeing that these software supply management attacks are on the rise, and considering how sensitive the data that the wallet that's managing is, we need some assurance about the legitimateness of the binary that we're running, basically, because that's the cornerstone, that's the main tool that the user has to manage its own credentials and show them to the verifiers. So, of course, that's helpful in preventing tampering and malware, and also validate open source, and it gives us trust that these updates are logged somewhere, publicly verifiable, and no malicious update has been swept into the update of the wallet app. And this there's also some implication here, like this could also be beneficial for the issuer, because also the issuer, before issuing these credentials to the user, he needs to have some assurance that the wallet that he's going to issue the credentials into is benign and is trustworthy. During the issuance, so going with the trend that we maintain the ecosystem as it is, but we build a transparency layer on top, we try to make the issuance process as less disruptive as possible. So now every time the issuer is issuing a credential, at the same time, he is, the issuer, it is publishing some record to this transparency log about the issuance of this specific credential. What's the challenge here? Of course, we have sensitive personal information, and that these transparency logs are public by design. So what are our goals when trying to build such a credential transparency system? First of all is we want to maintain the credential privacy, so we do not want to leak anything about the sensitive data that we're trying to issue. And also, if we have multiple credentials pertaining to the same user that are being logged in the same transparency logs, we want these entries to be non-related to one another. And because just pushing stuff into a log is not enough, we want that to be discoverable by the user. So we want some mechanism for the user to be able to identify all the log entry data that are pertaining to him. And we also want some way to enforce this logging. And that is a concept that we called verifier verifiability, which is how can the verifier be ensured that the correct credential for the correct user was logged into this transparency log. And we employ 3 building blocks when trying to solve this problem. Of course, on the center we have this append-only tamper-proof log. We have some blinding mechanism. Of course, we do not want to publish the credential. And we also employ some zero-knowledge proofs. So during the showing process, so when the holder is now showing a credential to a verifier, in order to enable the verifier to enforce the correct logging of this issuance, we also proof to the verifier, but in zero knowledge, so without giving him any extra additional information about our identity, that the blinding mechanism that was used when publishing to the log and the authentication mechanism that are using to this verifier both pertain to the same user ID, but we're not showing this user ID, this identity, this core identity of the user to the verifier. And yeah, we also have developed protocols for all of the 3 phases of credential issues, showing and discovery for that, and also done some initial evaluation and showed that it's feasible, even considering like a growth rate of similar to the certificate transparency, which is not the case for credential transparency systems. It's feasible for the user device to do this background monitoring of, has this issuer issued a credential on my behalf, and is this genuine or not? Going on to the next stage, so presentation. So this is a different problem setting at the design space. when I try to think of the mental model of it, it seems somehow more similar to key transparency to me, rather than just having a log of events of issued credentials. So we need to differentiate between two different design spaces. So we can either have device-stored credentials, so credentials stored on the user device, and also the key material that's associated with that, which is not always a good idea. And then we can also have like the possibility of having a remote credential management system. And especially in the latter case, we need to have some transparency guarantees that this remote credential management system is not showing a credential on behalf of the user without the user knowing that. So what would be the goal of such a credential presentation transparency system? The goal would be the user to be able to audit all presentations that are made on the user's behalf. And we still need to preserve the privacy and usability features of the system. So there are two ways to go with this. We can either go fully privacy preserving or less strict assumptions and say that we are preserving the privacy level of the underlying digital identity ecosystem. So if it's SSO or something, we are not leaking, we're not making privacy worse, basically. And there is also another perspective to this one. So the verifier, generally when doing this presentation process, asks for some attributes for the user. And the user has no means to verify whether this verifier is actually can ask for all of these attributes. So if we provide some sort of transparency to the presentation process, there's also some audit trail of was this verifier actually accredited to ask for this many features, or did he over-ask and we basically shared part of our private data without needing that. And finally, revocation, which is, I like to think of revocation as the gossip of transparency system, because there is no good solution for that, and it's messy in digital credentials. So generally, at least in our world, it's kind of swept under the rug and not dealt with in most papers. So during the presentation, verifiers need to confirm, of course, the status and the validity of the verifiable credentials. But when we're doing this revocation checks, we run into the risk of having traceability and linkability when we're trying to basically audit, to check the status of this. And there have been proposals. One of them is to have two trees, so basically one for issuance and one for revocation. So now when we are presenting a credential to this verifier, we give both a proof of membership that it has been issued to the issuance tree, and then we also a proof of non-membership that it has not been revoked, meaning that credential is still active. Another approach is the one that Facebook's auditable key directory takes, which is to have a single tree, but now we are marking this revoked credentials or keys in their case as stale, but by having that as an input to this verifiable random functions that determines the index of the entry. And yeah, that was all that I had. If you have any questions or even more welcome suggestions, I'm open for those.